Today we're talking about Chapter 8, Section 4, set operations and Venn diagrams with 3 sets. So obviously the with 3 sets means that we've done this with 2 sets so far. Now we're going to get a little more complicated, but not it. Realistically, it's just it's common sense. It's logic. I won't say common sense. It's logic. It's logical what we're doing in this particular section. So let's go ahead and get started with example 1 here. Alrighty, so set operations with 3 sets, right? Now obviously it says with 3 sets, but it looks like there's 4 here, right? But remember, this one right here is the universal set. It's everything, right? So set operations, let's see. Am I missing something here? Oh, yeah, maybe I should snip the part that we're finding, huh? Okay, so this reads, find A union with B intersect C, and let's actually do something a little bit different. All right, whoa, why did I do that? I didn't know that I could actually grab that. Okay. I'm gonna make this a little bit larger because we're gonna kind of slash things out. I feel like that's what I was trying to do in the last lecture, but it didn't work out quite that way. All right, we'll just put that here. Alrighty, so starting from the top, it says find A union with B intersect C. Okay, so let's look at B intersect C real quickly. All right, so B intersect C, where do they intersect? It looks like we intersect at 2, 3, and 6. Okay, so 2, 3, and 6 are where we intersect at, or where B and C intersect. I'm sorry. All right, so we intersect at 2, 3, and 6. And then the union of A with that, well, the union, again, is everything, right? It's going to be 1, 2, 3, 4, 5, as well as 2, 3, and 6. Well, we've obviously already mentioned 2, 3, and 6, so my union is just going to be, it's going to be 1, 2, looks like it, 3, 4, 5, and 6. Okay. Again, we found the intersection of B and C, and then we did the union with it. All right, so let's do B. B is one thing. A union with B. Okay, well, A union with B is all this. Okay, and then A union with C is going to be all of these. And then we're looking for the intersection of that. Okay, so this, we're probably not going to be doing too much circling here now. So let's go ahead and do the A union with B. Okay, so A union with B. Let's put this down here. A union with B is, again, 1, 2, 3, 4, 5, 6, and 8. So 1, 2, 3, 4, 5, 6, and 8. A union with C, hope I have room here, looks like it is 1, 2, 3, 4, 5, and then 6 and 7. So it looks like it's 1 through 7. So 1, 2, 3, 4, oh gosh, yeah. Trying to write small gets a little tedious here. These commas look like periods. 6, 7. Okay, so that's A union with C. Now we want to find the intersection of those. So we're trying to find what do these 2 sets have in common. Okay, well, they obviously have 1 in common, 2, 3, 4, 5, and looks like 6. So 1, 2, 3, 4, 5, and 6. Okay, and yeah, that's it. Yeah, that's all I have in common. 1, 2, 3, 4, 5, and 6. So I had to find the union of A and B, the union of A and C, and that's what I wrote down there in the blue, and then the intersection there. Again, I said was 1 through 6. So 1 through 6. So let's write that. I know, well, I'm not gonna say I know, but I'm sure that doing, homework isn't fun per se, right? But I just can't stress enough how much more enjoyable it is to teach this course than other courses that I teach. Okay, so anyways, so let's start with looking at C. We're gonna look at the part in parentheses again, right? Kind of the same thing, PEMDAS ish, right? So B union with C complement. Okay, so C complement. C complement is saying, okay, so what is in the universal set and not in C? Okay, so this is where we're gonna write C complement. We'll put C complement down here. Okay, so the universal set right here are the numbers 1 through 9. Okay, well, 2, 3, 4, 6, and 7 are also in C though. So C complement is going to be 1, 5, 8, and 9. So that's C complement. So B unioned with that. Okay, so oops. So B unioned with C complement. Okay, well B is 1, 2, 3, 6, and 8. Okay, so let's kind of running out of room here. So let's do this. So B unioned with C complement, buck, is equal to 1, 2, 3, 6, 8. So it's 1 is in both, 2, 3, and then C complement has 5, so put that 5 there. 6, 8 is in both of them, so put the 8 there, and then 9. So this is, that's a horrible squiggle there. That's also a horrible squiggle, but we're going to live with it. So that is B union with C complement. 1, 2, 3, 5, 6, 8, 9, then in the yellow. Then we're going to say the intersection of that. Okay, so we're going to now look at A, which is here, and then B union with C complement, which is here. Okay, so what is in both A and B union C complements? So, well, it looks like 1 is in both, 2 is in both, 3 and 5. Wrap it up, and that's it. So again, we found C complement, which is in blue, and then B union with C complement, which is in yellow, and then from there I just I looked at A here, and I said, okay, well I know A has 1, 2, 3, 4, 5, and then I wanted to find the intersection of what's in A with B, and again the intersection is in what is in both sets. All right. No mindless computation so far in this course. Instead, it's just just moving things around, looking for stuff, seeing what exists where. All right, so Venn diagrams with 3 sets. I was debating on taking away because in the last lecture, if you recall, I see these Roman numerals 1, 2, 3, 4, 5, 6, 7, and then 8 for universal. I was considering taking away, kind of marking those out because I feel like they kind of got in the way. Instead, I am going to keep them for these next few examples because uh, I feel like they're actually kind of useful this time. Okay, this is something else that I'm not going to necessarily talk about, but it's going to be on the notes. Instead, we're going to jump to example 2. All right. So I'm not gonna write these out. That like for instance, for A union B, maybe I don't know. No, I'm not gonna write them out. We're just gonna discuss them uh, based on the Venn diagram, right? Because we're determining sets from a Venn diagram. We're gonna discuss them and say them, and then I'll snip them because it gets kind of, especially writing on this little page, it gets kind of tricky writing on the little page. So we'll try that for right now. We'll see how it works. But anyways, I think that's a magnifying glass. This is the only class where this, I don't know why it is, but the textbook refuses to let me see my toolbar down here. Alrighty, so use the Venn diagram in figure 22 to determine each of the following sets. Okay, so A, we want to find set A. Okay, well A, again, is this, maybe I should circle, let's do a circle here. A is this circle right here. Okay, and again, of course you know that, but it just helps to draw over it. All right, well what are the elements in that set? Well, it looks like 11, 3, 12, 6, 5, and 7, right? And that's it. Okay, now set B, right? I'm sorry, not set B. B is wanting A union with B, okay? Well, if what I circled is A and this is B, right? Well, then it just makes sense that A union B is going to be this little shape here, right? That is A union with B. Everything is over here on the A side, strictly the A and not the B. Everything over here is strictly on the B and not the A, as well as the intersection. Okay? So my A union with B is going to be 11, 3, 12, 1, 2, 10, 6, 5, 7, and 9. Okay. And again, I will snip the solution. Um, let's see. Yeah, I will snip the solution. Put it on the bottom though. All right, so C, we have B intersect C. B intersect C. So B intersect C, all right, again, this is my B circle, and this is my C circle. So we're looking at where they intersect. Well, they intersect right here, and I probably should do different colors here. Let's do, I don't know, I want blue over blue is good. Kind of, I don't know. Well, we'll just stick with the red for right now. So obviously where B and C intersect are right here. Okay, so my set there is just simply 5, 7, and 9. All right, next up we have C complement. Now this is where it gets not necessarily tricky, right? But I mean, just looking at my Venn diagram, I also have to keep in mind I have a universe, the part that's part of the universal set that's not part of A, B, or C. Okay, and this is where it kind of gets tricky, and where I'm assuming some students might just be like, what? And then they'll see it and they'll be like, oh, okay. So we're wanting C complement, and if you recall, C complement is everything that is not in C. So if this is my C Venn diagram here, my C circle, well, pretty much everything that is not in there, right? So 11, 3, 12, 1, 2, 10, and then don't forget 4. Okay, that is C complement. And then lastly, and this one is pretty easy, I think. It is wanting A intersected with B intersected with C. Well, we conveniently make these Venn diagrams to where something like that is super easy to see. All right. Well, where do all three of these circles intersect? Well, they intersect right here in section 5 at 5 and 7. Not at 5 and 7, but the elements of 5 and 7. Okay. So let's go ahead and we'll snip this. Yes. Yeah. Well. Yeah. I'm just gonna put this on the page real quick. Yeah. What do you got? The number 4 or the Roman numeral? Oh, yes, yes. If I recall, when I did it, oh, hang on. No, you're good. Hang on. Let me finish what I was about to do real quick, and then I'll address that. I mean, I like to make these nice and neat. Um, put it down here. Okay, so when I said C complement, I said if I recall, I said this is C, and then I just marked everything out. All right. I might have not actually literally said the number 4, but it was implied, I guess. If I didn't say it, I'm terribly sorry. But yeah, it's basically everything that is not marked out. So it would be 11, 3, 12, 1, 2, 10, and 4. Yes. Right. I mean, to me, I think that's the best way I can go about showing drawing this out without trying to write down the elements. And of course, I don't want to write the or put the solutions up right away because people students' eyeballs just tend to fall down here as opposed to following along with what I'm trying to say. So I feel like this is the best way to go about it, and I think that's just the way the rest of the lecture is going to be, is where I'm just kind of talking. Okay, this one is pretty actually this one's interesting actually because it wants us to construct a Venn diagram. Okay, and now the way the textbook goes about constructing a Venn diagram is, I mean, it's correct, but I don't know if it's necessarily the way I would do things. Um, hmm. Actually, maybe it would be. Let's double check real quick. Yeah. So I mean, this looks like just a convoluted mess, all right, and it kind of is. But if you look up here, right, the way the textbook is doing it is they're getting the intersections of the three sets and then just kind of filling in the blanks here. And that's what we're going to do. And we're going to just go ahead and draw it up ourselves the the best we can. All right. In hindsight, maybe I could have gotten a Venn diagram blank slate here, but we're just going to. I wonder if I got a circle. I might have a circle thing. Let's see. Um, Maybe not on this one. Okay, yeah, we're just gonna have to deal with it. So we're gonna have one circle, and then I believe we just simply overlap like this, and then we overlap like this. Okay. Hopefully this hopefully this works. And we also have obviously the universal set. So we're gonna put this all in a humongous box here, like so. Okay. And then same way we've done before. This is going to be A, this is going to be B, and this down here is going to be C. Okay, so what are the elements in A? A, D, E, G, H, I, J. Okay, so this is probably where the textbook is a lot more concise about this, but I'm just going to go about um, looking at A and B. No, we're just going to do this. We're going to do A, D. I'm going to run out of room so fast. Okay. Okay. So first thing I'm going to do is I'm going to ask myself, okay, so what do all three of these sets have in common? Okay, well, look in here. It appears that they all have A. Well, no, they don't actually, because B doesn't. Okay, so they don't have A. D isn't in all of them. C doesn't look like it is in all of them. Um, E does though. We have an E here, E here, E here, and it looks like H as well. We have an H here, and H here. So E and H are going to be the ones that go in the middle because they're in all three of them. So let's go ahead and put that there. So E and H. And then we're going to simultaneously just kind of erase them from their respective circles. Okay. All right, next up, let's do A and B. Okay, so what do A and B have in common? Okay, well, it looks like they have a G, and that's it. They just have a G in common. So I'm going to put a G right here, and I'm going to erase the G's from both of them. Okay. Next up, what do A and C have in common? Well, it looks like A and C have an A in common. It'd be funny if they had A and C in common, but they just have an A in common. So we're going to put an A between these two. And again, we're just going to erase them. All right, what do B and C have in common? And they don't have anything in common. Did I do that right? B, E, G, H, L, A, C. Huh. Yeah, they don't have anything directly in common that A, B, and C don't. so there's nothing that's going to be put right here. Nothing. Okay. And well, that's it actually. So Now let's clean it up. So up here we have a D, I, and J. So let's clean that up. Make it D, I, J. D, I. Oh, that's a horrible J. It's not much better, but we'll live with it. And then we have a B and an L right here. Then we have a C right here. Okay. And in my universal set, don't forget the universal set. My universal set had A, B, C, D, E, F, G, H, I, J, K, L. Right? And if I recall, I don't remember saying K and L at all. Well, no, yeah, I did. There's L and okay. So what is in my universal set that is not in A, B, C, A, B, or C? Okay. Well, it appears that, and let's actually, well, we don't have to blow it up. We'll just mark it out. So we know that A is in a set, B is in a set, C is in a set. Looks like D is in a set. All right, E is in a set. F, I don't see F. F is not in A, B, or C. So we're going to put F down here. All right. Next up, G. We see G is in a set. H is definitely in a set. I is definitely in a set. J is definitely in a set. K is definitely not in a set. So we put a K here. And then L, of course, is also in a set. So that is, we constructed it. And let's double check here, make sure that we did everything right. D, I, J, G, E, H, B, L, blank, A, C, and then F, K. Yep, everything is good to go. So, like I said, and this is how everything is in life, right? I mean, some people do it their way. You like doing it your way. And honestly, I probably did do it the textbook's way in a sense. It's just I just wrote everything out in my circles and then just crossed things off. So you can follow along with the way a textbook does it, or the way I do it, or even cooler, you could do it your own way. All right. So next up we have proving the equality of sets. So let's see. We have probably should let's snip this going into the next section. All right, I think this is pretty important. So let's read it from the tippy top. Throughout section 3, you are given two sets, A and B, and their universal set U, and asked to find something like A intersect B, the complement of A intersect B, and the union of A complement and B complement. In each example, they resulted in the same set. This occurs regardless of which sets we choose for A and B in the universal set. Okay, so what we're saying here is it appears that the complement of A intersect B is the exact same as the union of A complement and B complement. Okay, so coming down here, it says we can apply deductive reasoning to prove the statement. Okay, so we're going back to the deductive statement, what we did at the very beginning of our semester here. Uh, we can prove the statement for all sets A and B in any universal set U. So in order to prove that they're equal, we're going to use Venn diagrams. In both sets, if both sets are represented by the same regions in the general diagram, then this proves that they're equal. Okay, so what we're going to do is we're going to prove this by saying that they are in the same um, region. Okay, so that the region thing that I said, that be pretty useful today. Well, here's how it's going to be pretty useful. Okay. So we could, if we wanted to, actually put things in the sets, but it's just easier not putting things in the sets, and we'll see what I mean by here in a second. Okay. And this is kind of in line with just doing variables, right? We said that. Well, no, we'll leave that alone. So starting off, the problem reads, use the Venn diagram in figure 23 to prove that A intersect B, the complement of A intersect B, is the same thing as the union of A complement and B complement. Okay, so let's first of all find the complement of A intersect B. Okay, so pretty easy. So A intersect B is right here. Okay, that's the A intersect B. Well, the complement is everything that is not that, right? Everything that is not in the middle there. So the complement must be regions. Okay, we're just doing regions. That I mean, we could put elements in there, but it's not really, it's easier not doing it. So my regions are 1, 3, and 4. Okay, and I'm just gonna put a, a yellow star underneath that to denote that that's those regions. Um, and then next up, we're going to talk about, and we're going to do this on the other side in blue, just to kind of drive the point home. So next up, we're going to do the blue side, right? So we're going to say the A complement union with B complement. Well, first of all, let's do A complement. So A complement, here's A, and what is not in A? Well, what is not in A? It appears to be 4 and 3. Okay, those are not in A. All right, well, what is not in B? Well, again, this is B. B complement is what is not in B. Well, what is not in B is 1 and 4. Okay, and so we say 1. And we've already said 4, so we don't have to say it again, right? I mean, this said, I mean, that those regions are the same, right? The region 4 is the same as 4. Well, we see through our deductive reasoning here, just simply looking at the regions of a Venn diagram, that this statement is indeed true. Okay, because I mean, yes, they're out of order, but again, we've talked about elements in a set. They don't have to be in order for them to be the same, right? They don't have to be in well, yeah. So we have 1, 3, and 4, and 1, 3, and 4. So we do indeed see that statement, or not that statement. We do indeed see that this is a true statement. Okay? It's written completely differently, but it is indeed a true statement. Right? And that leads us to De Morgan's law. And we'll put that on the current page as well, because it's important. Put that down here. Right. Can't really see it on Zoom because I got toolbars in the way. So I'm going to go ahead and go back to the textbook and read it from there. So De Morgan's law states, and again, this is just one of those things in mathematics. It's a law, but it's also like a theorem. It's something that you can use moving forward to say, okay, so I know that De Morgan's law exists, so I can move forward saying, another statement is true. Kind of like a lawyer saying, okay, so this is the law, therefore, this person did or did not break the law, right? So De Morgan's law states that the intersection of the complement of A intersect B is the same thing as the union of A complement and B complement, and the complement of A union with B is the same thing as saying the complement of the intersection of A complement and B complement. And for the record, um, this De Morgan's law. So when I was taking college courses um, as an undergraduate, I didn't get into De Morgan's law until I got into something called until I got to a class. It was a third year math course. Um, if for those getting a mathematics degree, called how to prove it, right? And we did a lot of things having to prove things. And I think it's pretty interesting that now something like Math 1010 comes along, and it's a class that students that aren't even going into mathematics can actually take this stuff, because to me, and again, probably to at least 99.9% of mathematicians everywhere, think that this is more math that is useful as opposed to, and I find it hard to believe if anybody disagree with me here, mindlessly factoring your brains out that you have done in your college algebra course or something like that. Um, Again, I don't know. It's just something I want to talk about because it's fun. De Morgan's Law is fun. All this stuff is fun to me. All right, so let's prove the equality of a set. It's wanting us. Huh. All right, so let's prove the equality of this set using Venn diagrams again, apparently. So yes, let's use a Venn diagram. So make sure that we're good here. Okay. So we're going to use the Venn diagram to prove those statements. So here's our Venn diagram. And again, what I'm going to do is I'm just going to pull the Venn diagram and just kind of talk my way through the solution, and then I'll just snip the solution at the end. Alrighty, so we're wanting to prove that the union of A and B intersect C is the same thing as saying the intersection, or is the same as the intersection of A union B and A union C. So let's look at the left side here. So what is B intersect C? Well, B intersect C is simply this portion right here. And then A union with that was going to be, this is A union with that, so it's going to be 1, 2, 4, 5, and 6. Okay, so we'll write that. So I'm not going to write Roman numerals if that's okay. I'm just going to write 1, 2, 4, 5, and 6, just to make things a little quicker here. All right, so let's erase that. Okay, next up, we're going to look at this. So what is A union with B? Well, A union with B, it's going to be all of this. Okay, so let's double over, just kind of really drive the point home. This is A union with B. And what is A union with C? Oh, we're doing intersection. I'm sorry. Okay, yeah. And then so what is A union with C? The intersection there. Well, A union with C. Oh gosh, this is where. Um, let's. What showed up better, yellow or green? Maybe green. Okay. So A union with C is going to be all of this. That's not terrible. Okay. And we're wanting to find the intersection of those two. Okay. So where do the intersections of the red and the green show up? Okay. Well, it's going to be this is awful. Well, let's trace it with our laser. Okay, so the intersection of these two is going to be going around here where the red and green connect, and then it's going to be wherever they cross in the middle of. Okay, so it's going to be all of this. This is where um, A union B intersects with A union C. Okay. So that's going to be, it looks like it is 1, 2, 4, well, 5 and 6. Yeah, because it is a true statement. So 1, 2, 4, 5, and 6, and that is indeed, we prove the equality of this set using a Venn diagram. And again, all I did was just simply, use a Venn diagram and drew some circles of where we have intersections and unions. And of course, like I said, I'm going to go ahead and also snip the solution. Like so. And that's it. Okay, so that concludes today's lecture.